In this video, we'll be considering divergence. Now, this is the formula of divergence. Now, in this video, I will show to you easy way you can memorize this formula without stressing yourself. Okay? Now, before we start, let's write out this vector B first. Vector B equals to 5x raised to the power of 3 y raised to the power of 2 I plus 3 y raised to the power of 2 z squared j minus x y z k. Yes, as I've said, I will show to you easy way you can memorize this formula without you stressing yourself. Now, you see this vector B, this I, J, K here simply tells us that it is a vector. Okay, now you see from here to here, don't consider this I, J, K. From here to here is taken to be B1, is our B1. From here to here is taken to be what? B2. And from here to here is taken to be what? B3. Okay, then to calculate the divergence of this vector, divergence of vector B, this is how we represent it. This is how to represent it. Divergence of vector B, this is how to represent it. Is equals to what? The divergence of vector B is equals to, just follow this simple thing I want to show you. For the first one, write B1. Here will be what? B2, B3. So for this one here, at the down here, start with what? X, Y, Z. Why are we using X, Y, Z? If you see this vector B is a function of X, Y, Z. You can see X, Y, Z here. You can see that they are here. So vector B is a function of X, Y, Z. Okay, so that's how we started from this first one, X, Y, and Z. Then you can see that this formula is the same thing as this. You can see it's very simple. It's very simple. Okay, let's proceed. The divergence of this vector, divergence of vector B equals to, what does this simply mean? This symbol represents partial differentiation. We make use of partial differentiation whenever we have two or more variables. You can see that we have two or more variables here. So if I'm to differentiate this vector B with respect to the variable, I will differentiate it partially because there are more than two variables here. We have two and above variables. Okay, so I'm differentiating this B1. You know, I said from here to here is B1, right? With respect to what? X only. There's another variable here which is Y. I'm not differentiating Y, but I will differentiate it with respect to what? X only. So what will happen to this Y and 5 here? I will take them to be what? To be constants. So I will take my 5 and Y square here to be constant. Then when after differentiating with respect to X only, whatever I get, I will then multiply it with this. Whatever I get, I will multiply it with this. So let's differentiate X raised to the power of 3. X raised to the power of 3, from our general method of differentiation, I've prepared video for that separate. You can watch it, but I will still explain it here. For my general method of differentiation, if I'm to differentiate this, I will use this power to multiply it, then subtract 1 from the power. That is, I will have 3x raised to the power of what? 3 times x raised to the power of what? 3 minus 1. I use the power to multiply it, that is 3 times this, then subtract 1 from the power. After you have multiplied it, you subtract 1 from the power. So here I have 3x raised to the power of what? 3 minus 1, 2. So here give me 3x raised to the power of 2. 3x raised to the power of 2 plus, I'm differentiating this B2 now from here to here partially with respect to what? With respect to Y. What will happen to this and this? I will keep them constant. So let me write the constant first. 3 z raised to power of 2. Then if I differentiate with respect to y here, I have y raised to power of 2. Using the same general method of differentiation, if I'm to differentiate this, I will use the power to multiply it, become 2 times y. Instead of me to write 2 here, I will subtract 1 from it. 2 minus 1. So this gives me 2 times 2 minus 1 will give me what? 1. That is y raised to power of 1. And y raised to power of 1 will give me what? Y. So it will be 2 times y. And 2 times y will give me what? 2y. So here is equals to 2y. Plus, then I'm differentiating this one with respect to what? This b3 with respect to z only. Sorry, this partial derivative, this is how to write it, not b. This is it. This is it. I'm differentiating it with respect to z only. So if I'm to differentiate this with respect to z only, I will keep this x and y constant. X, y. If I differentiate z, this is z. The same thing as z raised to power of 1, right? So if I use the 1 to multiply, it becomes 1 times z. I will then subtract 1 from the power, 1 minus 1. So this gives me 1 times z raised to power of 1 minus 1. 1 minus 1 will give me what? 0. That is z raised to power of 0. So z raised to power of 0 will give me what? 1. 1 times 1 will give me 1. So if I use the 1 to multiply this, it will still give me this x and y. So let's proceed. The divergence of vector b is 5 times 3, 15. Then if I'm to follow it alphabetically, you see that x comes first before y. So I will write x squared followed by y squared. X squared, y squared. Okay? So plus 3 times 2, 6. If I'm to follow it alphabetically, y comes first before z. So I will write y followed by z raised to power of 2. Y, z raised to power of 2 plus x, y. And that is our final answer. You can see that it's very, very simple. Please hit the subscription button, subscribe, like, comment, share, and stay tuned for more tutorial videos. See you in my next video.